Blockchain and smart contracts, automating transactions and agreements. Smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can be immediately certain of the outcome, without any intermediaries' involvement or time loss. They can also automate a workflow, triggering the next action when conditions are met. History of smart contracts. Smart contracts were first proposed in 1994 by Nick Szabo, an American computer scientist who invented a virtual currency called BitGold in 1998, 10 years before Bitcoin was introduced. In fact, Szabo is often rumored to be the real Satoshi Nakamoto, the anonymous Bitcoin inventor, which he has denied. Szabo defined smart contracts as computerized transaction protocols that execute the terms of a contract. He wanted to extend the functionality of electronic transaction methods, such as POS, point of sale, to the digital realm. In his paper, Szabo also proposed the execution of a contract for synthetic assets, such as derivatives and bonds. Szabo wrote, "These new securities are formed by combining securities, such as bonds, and derivatives, options and futures, in a wide variety of ways. Very complex term structures for payments can now be built into standardized contracts and traded with low transaction costs, due to computerized analysis of these complex term structures." What is a smart contract in blockchain and how does it work? Table of contents. What is smart contract? Benefits of smart contracts. How do smart contracts work? Smart contracts and flight insurance. Voting and blockchain implementation of smart contracts. View more. Contracts regulate most aspects of our professional and personal lives, and they are essential to the functioning of modern society. As an introduction to blockchain technology, smart contracts play a very essential role. It helps to make the transactions taking place more safe and secure and function in an organized manner. And not just that, it helps other components like applications running on these platforms be even more accessible. But what is smart contract? Smart contracts are computer programs or protocols for automated transactions that are stored on a blockchain and run in response to meeting certain conditions. In other words, smart contracts automate the execution of agreements so that all participants can ascertain the outcome as soon as possible without the involvement of an intermediary or time delay. Smart contracts are self-executing contracts in which the contents of the buyer-seller agreement are inscribed directly into lines of code. According to Nick Szabo, an American computer scientist who devised a virtual currency called BitGold in 1998, smart contracts are computerized transaction protocols that execute contract conditions. Using it makes the transactions traceable, transparent, and irreversible. Benefits of smart contracts: accuracy, speed, and efficiency. The contract is immediately executed when a condition is met. Because smart contracts are digital and automated, there is no paperwork to deal with, and no time was spent correcting errors that can occur when filling out documentation by hand. Trust and transparency. There's no need to worry about information being tampered with for personal gain because there's no third party engaged, and encrypted transaction logs are exchanged among participants. Security. Because blockchain transaction records are encrypted, they are extremely difficult to hack. Furthermore, because each entry on a distributed ledger is linked to the entries before and after it, hackers would have to change the entire chain to change a single record. Savings. Smart contracts eliminate the need for intermediaries to conduct transactions, as well as the time delays and fees that come with them. How do smart contracts work? A smart contract is a sort of program that encodes business logic and operates on a dedicated virtual machine embedded in a blockchain or other distributed ledger. Step 1. Business teams collaborate with developers to define their criteria for the smart contract's desired behavior in response to certain events or circumstances. Step 2. Conditions such as payment authorization, shipment receipt, or a utility meter reading threshold are examples of simple events. Step 3. More complex operations, such as determining the value of a derivative financial instrument, or automatically releasing an insurance payment, might be encoded using more sophisticated logic. Step 4. The developers then use a smart contract writing platform to create and test the logic. After the application is written, it is sent to a separate team for security testing. Step 5. An internal expert or a company that specializes in vetting smart contract security could be used. Step 6. The contract is then deployed on an existing blockchain or other distributed ledger infrastructure once it has been authorized. Step 7. The smart contract is configured to listen for event updates from an oracle, which is effectively a cryptographically secure streaming data source, once it has been deployed. Step 8. Once it obtains the necessary combination of events from one or more oracles, the smart contract executes. Smart contacts and flight insurance. Let's consider a real-life scenario in which smart contracts are used. Rachel is at the airport and her flight is delayed. AXA, an insurance company, provides flight delay insurance utilizing Ethereum smart contracts. This insurance compensates Rachel in such a case. How? The smart contract is linked to the database recording flight status. The smart contract is created based on terms and conditions. The condition set for the insurance policy is a delay of 2 hours or more. Based on the code, the smart contract holds AXA's money until that certain condition is met. The smart contract is submitted to the nodes on EMV, a runtime compiler to execute the smart contract code, for evaluation. All the nodes on the network executing the code must come to the same result. That result is recorded on the distributed ledger. If the flight is delayed in excess of 2 hours, the smart contract self-executes, and Rachel is compensated. Smart contracts are immutable. No one may alter the agreement. Voting and blockchain implementation of smart contracts. Using blockchain in the voting process can eliminate common problems. A centralized voting system faces difficulties when it comes to tracking votes, identity fraud, miscounts, or bias by voting officials. Using a smart contract, certain predefined terms and conditions are preset in the contract. No voter can vote from a digital identity other than his or her own. The counting is foolproof. Every vote is registered on a blockchain network, and the counting is tallied automatically with no interference from a third party or dependency on a manual process. Each ID is attributed to just one vote. Validation is accomplished by the users on the blockchain network itself. Thus, the voting process can be in a public blockchain, or it could be in a decentralized autonomous organization-based blockchain setup. As a result, every vote is recorded on the ledger, and the information cannot be modified. That ledger is publicly available for audit and verification. If you find this video useful, don't forget to like and subscribe to our channel.